Today's topic is the production of radionuclides. Let's see from where these radionuclides are produced. These radionuclides are produced either from nuclear reactors or cyclotron. Then these products are further processed in radiopharmacies. Then it is transformed into radiopharmaceuticals. Radiopharmaceuticals are then shipped this product into the hospitals where these radionuclides are used as a radio tracer in nuclear medicine because of its short off-life period, and it can also be used for other medical application. Cyclotron. The cyclotron is a device that uses electric and magnetic field to guide and accelerate the charged particle like protons and neutrons. This results in production of high energy charged particles. In nuclear physics, such energized charged particles are used to bombard a nuclide, causing nuclear reaction. A cyclotron follows a principle which is given below. That is, the charged particle can be accelerated by a given electric field, whereas the magnetic field can make that particle to move in circular orbit, such that its frequency of the revolution does not depend on its speed. Let's see the construction of cyclotron. The cyclotron consists of two hollow metallic cylinders called Ds, that is D1 and D2. These Ds are connected to two terminals of high frequency oscillator. High frequency oscillator would help in changing polarity of the Ds. That is, when D1 is negative, then D2 is positive. This creates the electric field between the Ds D1 and D2 in horizontal direction. In electromagnet, one is kept above the Ds and another is kept below the Ds. The bottom electromagnet will have north pole above and top electromagnet will have south pole below. This creates a magnetic lines which is perpendicular to the electric field direction. That is, the electric field is created between the Ds in the direction of horizontal, whereas the magnetic field creates in the direction of vertical. Finally, the whole setup is enclosed in an evacuated chamber. If charged particle lies, protons or neutrons are kept between the Ds, it is accelerated towards the D having a negative potential at the instant of time. Then due to the normal magnetic field, the ion experiences a magnetic Lorentz force which makes the charged particles to move in a circular path. By the time the ion arrives at the gap between the Ds, the polarity of the Ds get reversed by an high frequency oscillator. When a charged particle is kept between the Ds, it has the velocity 0 initially. When it enters the Ds, it has the velocity v and it remains constant because the influence of magnetic field does not change the velocity. Now the oscillator changes the polarity. When charged particles come out of the Ds, when it enters under the influence of electric field, the electric field oscillates the charged particles towards D2 with velocity v1. When it enters the Ds D2, it remains the constant velocity. Again, the polarity is changed. That is, the D2 becomes positive and D1 becomes negative. When this charged particle leaves the Ds, it again enters under the influence of electric field. This electric field accelerates the charged particles towards the Ds D1. That is, it moves from D2 to D1. When these charged particles enter the Ds D1 with velocity v2, it remains the constant velocity throughout the circular path. So under the influence of magnetic field, it experiences a centripetal force. These forces make the charged particles to move in circular path along the radius r with a greater velocity v2. When these charged particles leaves the Ds, it again enters under the influence of electric field. This electric field accelerates the charged particles towards the Ds D2. Now the velocity becomes v3. In this way, a charged particle will move in circular path. With each circle, the velocity of charged particle will increase. If the velocity of charged particle is increased, obviously the radius of the charged particle will also increases. Finally, when there is no more radius of the circle to be followed, the charged particles will be thrown out with very high energy to strike the target. When the particle moves along a circle of radius r with a velocity v, the magnetic Lorentz force provides the necessary centripetal force. That is, the magnetic Lorentz force BQV is equal to the centripetal force mv square by r. By cancelling the common terms on both sides, we get V by R is equal to BQ by M, that is equal to constant. The time taken to describe a semicircle is denoted by letter small t, that is, the small t is equal to pi r by v. Then substitute the equation 1 in 2, we get the small t is equal to pi m divided by bq. So from the above equation, it is evident that the time taken by ion to describe a semicircle is independent of two factors, that is radius of the path, another one is the velocity of the particle. So if the time taken to describe a semicircle is denoted by small t, then for complete rotation it is denoted by capital T. So the capital T is equal to 2t, then the capital T is given by 2 pi m divided by bq, it's equal to constant. So if you derive the equation in terms of frequency, that is the frequency of rotation of the particle is given by mu is equal to 1 by t, that is equal to bq by 2 pi m.